All right, so number 58, this is on practice 1. And number 58. I read through the problem when I did this, and I thought, what the world? Why would they put a geometry solid cube problem up here talking about the diagonal? And you can even see I put random, but then I realized what it's asking for. Look at the equation. It says D is equal to the square root of 3s squared, right? D is equal to root 3s squared, where s is the length of the side of the cube. If the diagonal of the cube measures 6 meters, which is true of the length of its side? So immediately, because my comfort zone is geometry, I'm going to my picture. And I go, well, what, huh? And then I looked at it and I read it again. And it said, let's see, the diagonal of the cube measures 6. The diagonal of the cube measures 6. What will be true about the side? Now, when do you know whether to square root or square something? What do we know? Well, what are we trying to solve for in this problem? We've got to solve for s, plain old s. Not s with a square root symbol over it, but plain old s. So how am I going to get a plain old s? How do I get it out of that box? How do I remove that box? Well, it's already under the square root. So if it's already under the square root, how do I get rid of a square root? Square it. What's the opposite? Square it. And what I do to one side, I have to do to the other. 6 squared is 36. And when you square a square root, what is your answer? It's that thing under the radical, right? So I have 3s squared. And now what do I do, folks? Now I just solve. Just solve for s. So here we go. Divide by 3. And I get s squared is equal to 36 divided by 3 is 12. And now what? I have to take the square root of both sides. Really? I just did that up there. Okay, but it's okay. Watch. The trick. Would it have worked? Did you try that? No, okay. And I haven't tried that either, but we'll do that. What did it say? It says it measures the root 12 or 2 root 3. What is that? That's just simplified radical, okay? And it gave you like 4 times 3, 2 root 3 as your side. So either one of those will be acceptable. And folks, this isn't answers. You know, don't think, oh, Miss Perry just did this and made up the answers. This came out of the solution from the book. These aren't my solutions. These solutions are from the book. So they're legit. They're not just, I don't know, sometimes you know what I'm saying. They're legit. I know how y'all look at me sometimes. It's all good though. Questions? Does that help on that one, Emily? Different. Go ahead. 19. These. Okay, hold on. All right, let me get mine. Hold that. So 19 is beautiful radicals. 3 plus root negative 90 minus the quantity 3 plus. Here we go. All right, this is total calculator problem, folks, okay? Now, here's what you're going to do. Emily, did you use parentheses? All right, first of all, you know, I've got to clear out your memory before you take that test, okay? And then you're going to have to put your calculator in what mode? We've got to put it in a couple of different things. Always be sure right now, until we get to trig, always make sure that your calculator is in degree mode. The next one is we want to make sure that our calculator is in A plus BI mode, okay, because that's for our imaginary numbers. And then go back to the home screen. What we're going to do is I'm going to see what this gives us. Of course, I think I worked it out on paper. Of course I did. Let me work it out here on paper or this smartboard. Now, I know I got a negative under the radical. So I know I'm going to have an imaginary number. So I break it down to negative 9 times 10 because I want the highest perfect square that goes into 90. 3 plus, what is the square root of negative 9? 3i. All right, so I've got that. Keep working on this side on the left. 3 plus, the square root of negative 9 is 3i root 10 minus the quantity 3 plus 3i. Yes? Everybody with me? Now, you are subtracting a quantity. So what number is here in front of this parentheses? It's there but not there. Negative 1. So now we got to remember, hey, I've got to distribute. Okay? So I'm going to rewrite 3 plus 3i root 10. Because I don't mind rewriting things 45 times. Minus 3 minus 3i. You guys right? You cool with that? Great. Now it's when I'm going to combine my like terms. My 3, plain old 3 with plain old 3. And then what? Well, I'm going to get, what happens to 3 minus 3? It cancels each other out. It's 0. I get 3i root 10 minus 3i. Okay, that's weird. But look at your options. Factor out the GCF, which is what? 3i. It's just like having 3x times the quantity, root 10 minus 1. You cool with that? It looks like D. That's because of that weird thing with the, and that's why you should always, let's look at it. Question. Yes. Yep. Here we go. All right. Emily, let's see what we can get here. Did you use your parentheses? Promise. All right. Root negative 90. So I'm closing the negative 90. I'm closing the first quantity. Yeah? Minus 3 plus, was it negative 9? Okay, that's closing that. It's closing that, closing that. Now, I'm not sure what that's going to be. And it's got this decimal I, right? Let's just see for kicks, because you said I wrote it down on paper and I got it right on paper, correct? All right, so let's see what this is going to be. 3i root 10 minus 3i. Alaba John Brown. That's how you can check it to be sure, okay? If you are good at algebra, you show all your steps, you're very meticulous about simplifying and moving, and then I would go with your gut. And I'm going to tell you what, that's what I told Nathan yesterday. I said, go with your gut, folks. Do not second guess yourselves. My favorite teachers said years and years and years ago, first thought, correct thought. If you will go with your gut 95% of the time, you're going to make the right choice. Do not second guess yourself. There's nothing wrong with going back and working something on paper and double checking with your calculator. That's not what I'm talking about. That's being conscientious, and that's what I want you to do. But don't second guess yourself and let your mind go crazy, thinking, ooh, wonder if I did this, or wonder if I did that, wonder if I do this, if this will. Just go with your gut, because you know, y'all will be fine. You will be fine on this test. I promise. Question. Did you have a question? First thought, correct thought. Remember that. Yep. Yeah? When you turn in, I want you to, let's talk about this. Number 15. This is your function. And it's something like this, okay? All right, it says, which is true of this function? And you go through and you look at option A, and it says it is constant, it is constant. What does constant mean? Straight line, okay? I don't see any part of a straight line in this at all. Do you guys? And you look from negative infinity to 0. Is this a straight line? Is this curve a straight line from negative infinity to 0? No. It is what? It's increasing here, and it's decreasing here. Do you guys agree with that? What is the turning point for this parabola? This parabolic shape. The turning point is at the maximum value of that curve. Do you guys agree with that? All right, now how do you find the maximum value of that curve? You use your calculator, and you find the max. All right, somebody hook me up, please. Sorry. The maximum value for this curve is, thank you. Oh, and look at my plots. When do we want our plots on, by the way? When we're doing the statistics with the dots. The stat, okay? Remember now, and this is a problem, when you're working on this and you're not getting the right answer and you're not getting the right answer, I'm not going to come up to you and go, got your stat plots on. I can't do that, and I'm not going to do that. So you got to remember, you got to be a calculator ninja with this. Look at it. Negative x to the 4th plus 3. And then let's look at the graph. Ooh, zoom 6, zoom standard. Zoom 6. Okay. It's kind of got a flat top, doesn't it? So if you wanted to zoom in, just trace, that's where I want to zoom in, because I want to see it. Ooh, it didn't do anything. What shall I do? Hit enter. Just hit enter. All right, now look at it. There is a clear turning point for that curve. Do you guys agree with that? Find the maximum value. Second, trace. Hello, option 4, maximum. Okay. Go to the left. Go to the right. I do not want to guess. Okay. That means that my maximum is, oh, what does this mean? 2.8691 e to the negative 4. That means it's 0, 3. And you can pretty much tell on that picture. Yes? Yep. Yeah, I undid my stat. I cut my plots off. Yeah. And that's all I did. Okay. You cool with that? Yeah, you don't need it. We don't want it on because it's not going to give us what we need. Okay? You cool with that? Okay. Keep looking at your options. Figured it out? Yeah. Keep looking at the options. Let's see. Is it decreasing from 3 to positive infinity, where x is 3 to positive? Is it increasing? Is it decreasing? No, that's C. That's option C. And then option D says that it's decreasing. Well, this is the only place it's decreasing from 0, where x, stop talking because you're being rude, to positive. from 0 to positive infinity. It is decreasing. Do you guys see that? The calculator will be your best friend on this function stuff. If you can, I'm telling you, this is coming from the woman who was about teaching Algebra 2. You can do this test if you can work your calculator. I have no doubt that more than half of y'all are smarter than I am. Way smarter than me. And I'm not downing myself, I'm just stating the fact. Y'all some pretty smart cookies, okay? If you can work your calculator, you will be fine. Because I can work my calculator, and this is a piece of cake. But it's easy to work when you have the answers to go towards. Okay? Yes. I'm done with that one. Did you? You're cool with that? The answer was whatever D. Right. Go ahead. Yep. How do you plug it in the calculator? Look what it's asking. Number 39, because this is when you kind of have to back up and go, whoa, hoss, okay? Look at what it says. Each graph below shows f of x equal to 5 to the x power, which also shows its what? When we went over inverses, the biggest thing that stuck in my head was that inverse functions will be a reflection about what line? The parent graph. So Ted, if my parent graph is going like this, and I have an original function that looks like this, then it better go something like this. It better be a reflection about the parent line. I don't even care, because I know that inverses will be reflected about the parent graph. No, because y'all aren't going to be dealing with oblique asymptotes. So not in this. Calculus, yes, not in Algebra 2. Other questions? Folks, now's the time to ask, because here's what's going to happen on Tuesday, Monday. Tuesday, you're going to pass your test. Piece of cake. I think it's, from what they told me this morning, I think they are trying to test all math first block. Keep your fingers crossed, because that's what y'all need to do. I would be in there forever if I had to take the test. And it's fine. I'm not going to come by you and go, whack, hurry up. I'm not going to come by and whack you in the back of the head, okay? I want you to take your time. Now, if that changes, I will let you know. And I will let you know where you are to be. And it is all business that day. Which number, Mariah? 17?
Look at number 2 also.
I will. All right, so let's look at 17. So I got to put this on my web page. Not that anybody's going to look at it. Yeah. Second test. They are here, folks, if you weren't here yesterday. They should be in correct order. Yes. $30. Courtney, will you pause? Okay, there you go. All right, 17. Mariah, you see this right here? Okay. Here's something you need to think about, folks. Look at what this is asking. It says, which is true of the zeros? The multiplicity. I got to look that up. And I have a question here. I've got to look that up. But If I were just asking you, what are the zeros of that function? Don't worry about it saying the zeros of multiplicity. I truly have to look that up myself. I didn't get a chance to do that because Sadie's fever went back up yesterday. What would the zeros of this function be looking just at the graph? -2, 0, and 1, right? Okay. So your zeros are where the graph crosses the x-intercept. What are all the different words for zeros? Zeros, solutions, what? Roots, and what? X-intercepts. They are interchangeable, okay? So my zeros would be, you told me one more time. Okay. Now, let's take that a step farther, just for kicks. I'm going to look that up, and I'll let you know about multiplicity on Monday. Or, Monday. What would the factors of this be? X plus 2, X plus 0. Do you guys agree with that? All right, now let's think about this. This is the part that's weird, okay? And this is what I think this has to do with. I think because this is sitting on top of the x-axis, I think that has to do with the multiplicity, because I know that this is of what degree? It's 4th degree polynomial, which means that my options for solutions will be how many real solutions? What are all the possibilities? I could have 4 reals or 2 reals and 2 imaginary. Or, what's my last option? 0 reals and 4 imaginaries. All right, I can tell you right now the answer is C. The answer is C to 17. Write it down. C, which said that the 0, 1, oh yeah, that's, the 0, 1 has a multiplicity of 2. I know what it has to do with. Y'all remember us talking about, we talked about it very briefly about double roots. This has to do with double roots. If I were to have a perfect square trinomial, like, because this one touches it just it sits right on top of the x-axis. I know that's what it has to do with. It has to do with it being a double root. But this is why. If we had what if that, go get you some water if you need to. Okay, keep coughing. How would I factor that? It'd be 3 and 3 plus and plus, right? Okay, now how many zeros of -3 will, we would set both of those equal to 0, and our root would be -3, wouldn't it? All right, but there are 2 factors for that. So that's why 0, 1 has a multiplicity of 2. That means there's a double root there at the 0, 1, right here. That's a double root. That's why. I don't even need to look it up because I know that's why. Okay? Multiplicity. Covering 2 things. Yeah. Covering 2 factors. Yes. Yes. What was your question, Catherine? Same problem? Okay. Okay. 18? All right, graph it. Graph it, graph it, graph it, graph it, graph it. Couldn't figure out which one? Catherine, you got this? Okay. 18. 18 is weird because it's that exponential function, okay? It says which describes how the graph of f of x is equal to 2 to the x power was transformed to h of x, which is 4 times 2 to the x. And it shows you there, okay? But what happens to functions that have been vertically shifted up or down, even if we relate it to parabolas? We know that x squared is going to look like that right there, correct? If I shift that up 2 units, then what would my function, I'll call it g of x. What would my function be if I shifted it up 2 units? It'd be plus 2, wouldn't it? Now, if you were unsure of that, put it in your calculator. But that's what we're talking about. All right, now look at f and g. Has that function been shifted up 2 units or 4 units? And they haven't. F, if that were the answer, shifting up 2 units would be the equation 2 to the x plus 2. And if that were the answer, then the equation h, the h of x, would be 2 to the x plus 2. If it were g, where it says being shifted 4 units up, then my h function would be 2 to the x plus 4. That's what it would have to look like, okay? And then I got it narrowed down to h and j. And then I put both of those in the calculator. And where it says on option H, it said it was shrunk, vertical shrink by a factor of 1/4. I did this 1/4 times that function. And when I did that, it gave me something that looked like this right here. It was a long, and then it swooped up way far out there. Okay? Swooped up. That was really technical. And then J was the same thing that's already graphed. A vertical stretch by a factor of 4, which would have been what we were given. That H function was already 4, and it was what? It went up through 4. 1, 2, 3, 4. I just started narrowing them down. But I know if it's a vertical shift, it's going to be plus or minus on that function. Ted, what does 27 mean? Practice 2? 27. All right, you're given that x has to be greater than or equal to 0. You're given constraints. You're given an f function. Which is 4x squared. You're given a g function, which is root x over 2. And then it says, are the two functions inverses? Well, how do you determine if two functions are inverses of each other? You do the composition of functions. You find f of g of x, and then you find g of f of x, and they both better be equal to what? They both must be equal to x in order for them to be inverses of one another. Have a good weekend. Do a little bit of work. Hope y'all feel better.